Alright guys, welcome back to robotics class. Today is the day that we begin doing our computer coding. We're going to be connecting our computer to this guy right here. So before we do that, let's go ahead and review what we've done so far. So this right here, this is our button circuit. So when I press it, it turns on. When I let go, it turns off. Alright, so I'm going to go ahead and draw this just as a review so that we can see how we can change it so that we can start using our computer. Alright, so here we go. We have our battery here. We've got our resistor, a light, and then our button connection. And it goes like this. Okay. So when we press it, we have electricity is able to flow through it and then all the way through from the top leg to the bottom leg of the button, and it goes all the way through. Okay? So another way to say it is that press means it's on, and then we also, another way to say that is closed circuit. Alright? Now when you don't press, the light's not on, right? So no press goes to off, which also means not closed circuit, but open circuit. So another way to think about this, guys, is that this button right here is controlling whether I have a closed circuit or an open circuit. Alright, so the button controls the flow of electricity. And that's why the light turns off and on, depending on whether or not I press the button. So here's the next question. So what if I wanted it to be like where I want the light to turn off and on, but I don't want to press it with my finger? I want it to be able to just automatically turn on and then automatically turn off. Well, this is where you need to add in a computer. Alright, so let me draw a new circuit here to show you what that looks like. I'll draw a box here. This box is going to be our controller or our computer, and I like to call it our noggin. Noggin's like another word for a head or a brain, and I like to say that a computer is like a brain, so that's why I call this a noggin. Okay, and I'll draw this here so we remember it is a brain. Alright, so we go noggin, and then what's going to happen is that if you remember, our noggin, which is this guy right here, the computer, also has power in it. So actually what's going on is that inside of it there's a little battery or a heart. So in human terms we call this thing the heart, right? But in robot terms, brain is the same as computer, and the heart is the same as power or battery. I'll just write power for now. Okay? So inside of the noggin there's already power. That's why we can just take the 5V from here. You know, we didn't have like an extra battery or anything, right? We just took it from the noggin. Okay, so the noggin has the power and it also is the brain. So let's see how this connects. we're going to go 7 resistor LED. And then I'm going to put minus here. Okay. What is minus? Minus is the same as G and D. So when we connected right here, going back to this schematic right here, this leg was connected to G and D. So that's why I'm putting minus here, because it connects to minus here. Okay, so what's going to happen here is that the plus of the battery is actually, of the little heart, is connected to 7, and that can then cause electricity to the flow here through the resistor, through the light, and then all the way back through to the minus, and that's how it's going to turn on the light. So the power will be, the plus of the power goes through 7, okay? Now what happens if I can actually disconnect the power from the 7. So if I disconnect power, like I just kind of get rid of it like that, then power is not going to 7, and I'm going to have no power in my circuit. So it's going to be like an open circuit because it's got an opening. There's no power connection. Okay? Okay, so what's going to happen is pin number 7 will control open, closed circuit. Okay? So that's what we got to think of now. Now pin 7, this is controlling. Before it was the button that was controlling open and closed circuit. Now it's going to be pin number 7. All right, so here's another thing that I think will help us understand. I always like to talk a little bit more of how to relate the robot to real life so that we can better understand things. All right, so I mentioned that the noggin is the computer in robot terms, which is a lot like the human brain. So I want to talk a little bit about the human brain, this guy here. So what is the human brain? Well, the human brain is a physical thing, like just like this thing. You could touch it, you could feel it, like it looks like, I'm going to draw it. Kind of looks like this, right? If you've seen pictures of a brain. Right? And now, in and of itself, like if it's just the human brain and it doesn't have anything inside of it, it's just a thing. It's just an object. But what makes it interesting is what actually goes inside the human brain, what lives inside of the human brain. So what is it? Well, I like to think of it in two ways. One thing that lives inside the human brain, you have memories. So, for example, everyone just think for a second about memories of when you were a little kid. For me, for some reason, I think of drinking Slurpees. I just love I don't really have Slurpees now, but I used to just love Slurpees. So that's some information or a memory that's in my brain. Okay, another way to say memories, or that has to do with it, we call it knowledge. Okay, so whenever you learn something in school, like what day is Independence Day for the United States? It's July 4th. Great. So that's something where I just have that fact because a teacher taught me at some point, and that becomes knowledge because it's just living inside of my brain. Okay, so that's what's now the other thing that is inside our brain is we have the capability to make decisions. So I call it decision making. So our brain allows us to think. When someone says, hey, can you do that? Your brain allows you to think, well, do I want to do that? I have a decision. So I'm not created to just do whatever people say, right? It's like I can actually think about it. Is this a good thing? Is this a bad thing? Okay, and a lot of things go into the decision making, like things like you have feelings that goes into it. You have your personality. Like when all of us encounter the same thing, if all of us encounter the same thing, we all react a little bit differently. Like, we could all look at hamburgers. Not everyone likes hamburgers. It's kind of hard to believe, but like I love hamburgers, but not everyone will like it automatically. And that's part of your personality, kind of like who you are, how you're made. So it's just we view the world differently. We have different feelings, and so all that goes into the decision making. And then also we have knowledge and memories. Those things also go into decision making. Okay, so that comes out together. I like to lump all this together. All the decision making and the feelings, the personality, knowledge, memories, like all that stuff coming together, and that creates like our character. Okay? Now the character is kind of, I'm not talking about characters of stories. I'm talking about, when I say character, is who you truly are. So your memories, your knowledge, your decision making, which is influenced by your feelings, your personality, that creates your character. And then you get into conversations of, well, are there good decisions? Are there bad decisions? If there are things like good decisions and bad decisions, are there things like good feelings, bad feelings, good personality, bad personality? Is there something like good character versus bad character? Okay, so this is more of like on the human side. Now, how does this have to do with robots? Well, I'm going to change the color here. Number one, memories and knowledge. This is called data for a computer. So for the robots, it doesn't have a brain, right? It doesn't have that gray squishy or pink squishy fleshy thing that's a brain. It's a real computer like this. So it's not memories and knowledge that's inside here, it's data. So data is just like information. So if you can store stuff, like if you think of like right here, this is my phone right here, right? And inside there, I have data. I have information. I have contact information. I have my calendar information, so I know not to miss my meetings, stuff like that. So that's all data. And I can change that data, and I need to make sure it's all up to date, right? Okay, so that's data. Now, what about this decision making, the feeling, the personality, the character? We'll call that the logic. Okay, so the logic is the stuff that you put inside the computer that basically determines what decision the robot does, or what decision the computer makes. That's called the logic. Now, just a little tidbit before we move on and actually try to do this. A lot of people say that robots and humans, we're different, right? We have similarities, but we're not the same thing. But there's this area of study now, you may have heard it. I'll write it. AI, artificial intelligence. So what is that about? It's basically this, guys. AI is the study of for logic and data. So these are our robot terms, right? How close can we get data and logic to be like the human brain? How close can logic become like character and data become like memories and knowledge? And so when computers first started, they were super different. You know, you wouldn't talk about the character of a robot. There's no such thing as a good robot and a bad robot. It's just a robot that followed logic, that just followed the orders, right? But what if you could now make a robot that could have feelings, that could have a personality, that could make decisions, and they could make a good decision and also maybe decide to make a bad decision. Also, a robot that is able to learn to create knowledge. Like, if you imagine you put a robot inside a classroom, and inside that classroom, it could be sitting next to you, it could be learning what the teacher's teaching and then get smarter over time. So all of a sudden, the data is more like memories and knowledge. And then if the robot could actually become a better person over time, the logic has now become like character. So that's the study of AI, and you have these conversations of, you know, are robots going to take over the world, and is AI going to be the end of the world kind of thing? So that's where all this conversation comes from. Okay, so it's good to understand where it comes from. It all comes from the fact that the brain is like a computer, and then when we're talking about AI, it's the stuff that goes into the computer. Or in the human, it's the stuff that goes into the brain. All right, so let us move on. Before do that, this stuff, let me change colors one more time. The stuff that goes in, like this arrow right here, the stuff that goes into the brain, it's called software. And the study of engineering would be called software engineering. So if you think about it, think of any type of computer device, something that is able to store data and make decisions or do execute logic. A smartphone. Smartphone is a computer. So anything that goes on into the smartphone, like apps, that's all software engineering. Websites, email stuff, Twitter, right? Whatever. Those are all software engineering jobs. So if you're into that, you would be into software engineering. Another one would be like computers, like laptops or Chromebooks, like you guys have, right? All those, all the software, all the tools that you use on your Chromebook, those would be built by software engineers. Okay, so just give you a sense of that. So if you like this portion of the class, you might be into software engineering. You might be a new, a budding software engineer. All right, so now that we know that, let's see if we can actually do this. So we're going to make this, first we're going to connect this together. So we're going to modify this circuit so it matches my schematic here. And then what we're going to do is we're going to put in the data and the logic to turn the light on. All right, let's do this. Okay, so I have this. My circuit here does not have a button, so let's go ahead and get rid of the button here. Okay, done. And I guess it has everything else. So let's see. I'm just going to go ahead and pull these out here. Okay, I'm going to also unplug that. It's a good idea. Let's pull these out. So first thing is I'm going to start here. I always said start on the plus. So the plus is connected to the 7. So the 7, what you need to do is you look here. You see these yellow rows right here? If you go across, you'll see 0, 1, 2, 3, 4, 5, all the way to 13. find column 7. Okay, so 7's around here. And then going up, you'll see GVS. You want to get the S row. So 7S is going to be here. There we go. Now, what does S mean? To give you some context, G is for ground. V is for volts or power. So those are your plus and minus. And then S is for signal. So one way to think of what a signal is, it's like a nerve. So imagine you have a brain. Your brain needs to send signals through nerves to tell your body what to do. So 7 is like a nerve from the robot. Okay? So I'm going to take the nerve, number 7, and connect it to my resistor here. And following my chart or my schematic, that goes to here. The resistor connects to the LED. And then the minus of the LED goes to the minus on the noggin, which is same as G and D. So I'm going to click that in, and then G and D. This is a G and D here. It's a bunch of G and Ds. Again, any G and D is fine. Okay, so now I'm connected up. And let's see if I can change its personality. Well, first we got to power. Yeah, we got to power it on. So I go like that. Okay, light's not on. Let's go ahead and change its personality. So right now, well, actually, look, the light's on. You know what's going on is probably I have a personality that's already on there. So you know what? I'll leave that on. So my challenge will be to program it to turn off. Okay, and then I'll also turn it on. So let's go here. Here's what you got to do now. Number 1, make sure that your cable is connected securely on this side and also on your Chromebook, okay? So mine's good, it's on, good. The next thing is we need to go to a website called code.barnabasrobotics.com. All right, now I've gone there. Let me move this out of the way here. Now I've gone there, and then you're probably going to get the same error here. What this is saying is that your computer is not yet set up to talk to the noggin right here. So you got to make a setting. So we got to go here, Chrome://flags. I'm going to right click and copy this and then put it up here. Okay, so here there's a bunch of flags here. You don't want to look through all of them. So in search, type experimental. And the one that you want is this one, experimental web platform features. Right now it says disable. Let's go ahead and enable that. Great. And what's going to happen here is that you need to make sure you click relaunch, all right? So that's going to reset. Okay, I'm going to relaunch. And great. So now that you're relaunched, let's go back to that web page, code.barnabas. All right. Let's move this again. All right. So here we go. A few things to check here. So this is our website here. This is where we're going to write the personality for our noggin. Okay. And then once we wrote our personality, we have to send it over to our noggin so that it actually does something on this side. Now to send it, you got to click upload. All right. So I'm going to go ahead and click upload. Right now I have like a blank personality, like nothing. So maybe if I put a blank personality in, it will turn off this light and do nothing. So let's do that. Upload. Oh, I get this error. Blah, blah, blah. You need at least a void setup to compile. Okay, so that's lesson number 1. We can't just send completely blank. We have to send something to it. So let's go ahead and do that. So I want you to type what I'm typing here. Setup, sorry, go back. Void space setup parenthesis. And then when you do that, this other parenthesis just comes up. So let's go, and then space, let's do a curly brace. So this is going to be where, after this is where we put our code. And I'm going to go like that, and then this other curly brace sets up automatically there. All right. Now, to make sure everything's okay, one thing to do, go ahead and click compile. And what that does is that it checks to make sure that you spelled everything correctly. So let's compile. And it says, still no good. I get this like error here because it says undefined reference loop. So I'm kind of doing this step by step so you kind of see all the checks that we need to do. So we're missing a loop. So I'm going to space or enter, right? And then I'm going to write another portion of code. I'm going to say void space loop parenthesis curly brace. Okay. Now let's try to compile again to make sure I spelled everything correctly. Compile. There. Okay, now I get that check mark. Good. So now that we've done that, let's go ahead and upload. Now before we upload, let's check one more thing. Make sure the board is noggin. Okay. This also says Uno, but let's do noggin. Okay. The lesson doesn't matter. Just leave it there. All right. And then let's click upload. This will come up. Make sure you then go ahead and select your device. If you had many devices, it may show up, but I only have one. You probably only have one too, so just click on it like that and then click connect. Once you do that, it's going to start sending code. Check mark came, and check it out. My light turned off. So this send a blank personality. You can't just send totally blank, right? You got to put these two things. So now that I've done that, I just want to explain briefly, what are these two things? So I call these things, these are called functions, okay? So there's two of them. There's a setup function, and then there is a loop function. The way this works is that these curly braces here, see the setup has these two curly braces, and loop has these two curly braces. That determines what the function does. So whatever code I put inside setup, if I want to put code into the setup function, I have to make sure I put it into this section. If I want to put code into the loop section, I got to make sure I put it into this section. Okay, so I'm going to totally ignore, don't worry about what to put into this function. For now, let's just look at the setup function. So here's what we do, guys. We're going to set up the pin mode. So this is how you do it. Pin mode 7, output. We're going to set up pin number 7 to be an output. And then I'm going to do a new line. Digital write 7 high. Okay, so let me explain a couple things before I click upload. Right now in setup, I have two commands. I have this command here, which is on line 2, and I have this command here, which is on line number 3. Line number 2, what this does is that it's saying number 7, which is the orange wire, the nerve number 7, I want to make sure it's an output because I'm going to be sending a nerve out to turn on the light. There might be times later in the future where we're actually going to be receiving stuff like feeling things, and so in that case it's going to be the opposite of output. It's going to be input. But for now, because we're doing sending something to turn the light on, it's going to be an output. Then we have this semicolon. we have to make sure we have the semicolon here. It's like the period of a sentence. Okay, if you don't have a period of the sentence, people don't know when the sentence ended. Okay, so make sure we have that semicolon. And then we have this line here. So let me bring this back to line 3. Digital write 7 high. What this does is that this digital write is the same as changing the nerve 7 to be high so that it's connected to power. So once you connect 7 to power, your light should turn on because we'll have a closed circuit. All right. And one more note, guys. You notice that this is lowercase here, the P, and then capital M over here. This is called camel case. The reason it's like a camel because it kind of goes down and up again and then back down again. So if you had more words, like if I wanted, if this existed, like pin mode, you would have a capital M here. The way that camel case works is like this. When you put, when you have functions with multiple words, you can't have any spaces. Like I can't do this. I'm just erasing. I can't do pin space mode. It doesn't understand that. I have to do one word, but then the first letter of the other words are going to be a capital. The reason it does that is, look at this. Pin mode, like line 2 now, I can't really read. It's just harder to read, right? But if I go like this, it's obvious to me that mode, that capital M, is the first letter of the second word. So that's why we do that. Also, if I have a lowercase there and I try to click compile, remember compile double checks your spelling and everything, I'm going to get an error. Okay? So we got to make sure everything matches correctly. Okay? So we got to make sure that the spaces match. We got to make sure that the capitals match, like the capital M there. Okay? And then let me compile now, and everything's good. Okay, so I have that. Let's go ahead and upload my new personality that sets the nerve 7 high. Let's upload that. And remember, every time you got to make sure you click on there and click connect. Check it out. My light is on. Great. Now, let's go ahead and change our personality so that it turns off again. How do I do that? Well, I could send it blank code again. Remember, because I did that the first time, turn it off. But actually, you can change the high to the opposite, low, and then we upload, and it should turn off. So let's upload, click here. And then we turn off. All right, so that's all we got now. So the next time that we meet, I'll explain a few more exercises, but just wanted to get our feet wet with the coding, understanding how the noggin works and how we take the personality or computer code and send it over to the noggin to make it do stuff. All right, we'll see you next time.